Welcome to Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we'll be answering the question, how do you solve rational equation applications, hint, hint, word problems, involving time in motion? So we're talking about that formula that you're probably very familiar with, distance equals rate times time. So the first thing I have written on the board here is I've taken this formula D equals RT and I've arranged it solving for each of the variables because you're not ever sure which form of this formula that you're going to be able or going to need to use to solve your application problem. So we have distance equals rate times time, and then if I solve for the R, I just divide both sides by T, so I get rate equals distance over time. And if I come back here and want to solve for T, I just divide R off of both sides to get time equals distance divided by the rate. So that's all three forms of that particular formula. So the first thing in this process, besides read the word problem, is to identify the meaning of the variable. And you're going to decide what to assign a variable to by looking at the question that the problem is asking. So what are you trying to answer here? If you're answering a question, like if they say, what was the distance? Well, obviously you don't know the distance, so that's where you're going to need to assign your variable. Then you're going to set up your DRT chart, and this will make a little bit more sense when we take a look at our example. You want to use that chart and the information in the problem to see where you can put an equal sign. So what can you equate from the chart to create the equation that you're going to solve? Then after you figure that out, you actually write the equation, solve it, and of course check it to make sure that your solution is actually a solution and not just an answer. So let's take a look at this application problem. All right, so you're canoeing down the Colorado River. Sounds nice. In still water, so this is not on the river, but in still water, your average canoeing rate is 3 miles per hour. It takes you the same amount of time, and actually that should say of time, but I'm not going to redo this whole video because I fixed it by just writing over the I. Same amount of time to travel 10 miles downstream with the current as 2 miles upstream against the current. What is the rate of the water's current? So in looking at the question that we're going to be answering in working through this particular application problem, we need to identify our variable. So what is the rate of the water's current? Well, we don't know the rate of the water's current, so we'll give it the variable x, and we want to always note what we're using that variable to stand for. So I'm just going to put rate of water's current. So now we know what our variable is standing for. So let's see if we can pick out information in the problem above to help us fill out this DRT chart below. So we have two situations. We have you traveling with a current and against a current. So in going back up to our problem, we see it takes the same amount of time if you travel 10 miles downstream with the current as it does 2 miles upstream against the current. So when we're talking about 10 miles downstream and 2 miles upstream, we're talking about a distance. So we have 10 miles downstream with the current and 2 miles upstream with the current. Now moving on to our rate column, we want to talk about how fast we're moving in each of these situations. The only piece of information that we have about a rate is that when you're in still water, you can canoe an average of 3 miles per hour. But if you're in the river, if you're going downstream, you're going to have the current working with you to push you faster. If you're coming upstream, you're going to have the current working against you, which is going to slow you down. We all know that it's no fun trying to row upstream because you've got that current pushing against you. So when we write our rate, we have to take into consideration the rate of the current as well. Well, the rate of the current is x. We don't know what it is. So with the current, we can go 3 miles per hour plus whatever rate the current is helping us move. Now, when we're coming up against the current, it's working to slow us down. So we know we can row 3 miles per hour, but we have to subtract the rate of the current because it's working against us to slow us down. So now we've expressed both of our rates in terms of how fast we can actually row, added to or subtracted by the rate of the water's current, depending on which situation, if you're going with the current or against it. Now we use our formula T equals distance divided by rate, because we haven't been given any information about time except for one small thing, and that's that it takes the same amount of time to travel down as it does to travel up. And we'll talk about what that means in regards to your problem in just a moment. But we can express our time using our distance and our rate. So notice time equals distance divided by rate. So our time here is 10 over 3 plus x, and our time here is 2 over 3 minus x. Now, going back to our problem where it says it takes the same amount of time. If something is the same, that means you can put an equal sign between them. So you can use this last column to set up your equation. And our equation is 10 over 3 plus x is equal to 2 over 3 minus x. So we have a rational equation here. And we know from previous videos, to solve a rational equation, you multiply every term in the equation by the LCD. The LCD here has a factor of 3 plus x and a factor of 3 minus x. So we simply multiply every term by 3 plus x times 3 minus x. And I'll just note again that that's all happening in the numerator. And we do that so we can come back and say anything divided by itself is 1. And now we're left with 3 minus x times 10 equals 2 times 3 plus x. So distribution bells and whistles should be going off because that's exactly what we need to do. 3 times 10 is 30, and negative x times 10 is negative 10x. 2 times 3 is 6, and 2 times x is positive 2x. So we have a nice, neat linear equation to solve here. So I'm going to subtract 2x off of both sides and subtract 30 off of both sides. So that takes care of that term 2x, and this takes care of that term of 30. And our resulting equation is negative 12x equals negative 24. Divide both sides by negative 12. And we get x is 2. Now with any word problem, you always want to look back up and see if you're answering the question here. So x is standing for the rate of the water's current. We'll check this solution before we make our final declaration of what this solution is. So we go back to the original equation, 10 over 3 plus 2. and that should equal 2 over 3 minus 2. Simplify down each side. Let me just give a little barrier here so things don't get confusing for you. That's all the check on the right-hand side. So we have 10 over 5 equals 2 over 1, and 2 equals 2, so it works. Our final answer is the rate of the current is 2 miles per hour. You always want to make sure you answer in a complete sentence. This just shows your instructor that you understand what the meaning of your solution is. So I hope that this has been helpful for you. This is a pretty involved problem here, but you'll see quite a few examples like this. So please make sure you watch back through and understand where each part of this solution or part of the problem came from. If you have any other questions about solving these time and motion problems, please make sure to contact your Highlands instructor. Thank you.